Hi, welcome to the Calculus 1 lecture series. And this will be our last topic about the applications of differentiations. So we're going to wrap out the derivatives part by introducing the optimization problem. So this will be the application to use the derivative, first derivative, second derivative techniques we know to optimize the problems. So this is another application of the differentiation. Okay, so let's go ahead and get started with our lecture notes here, okay? So the first things here, before we do the problem, so I like to write down the few procedures. And those are the procedures, you can kind of the general guideline to follow, try to solve the optimization problems here. So the first steps here, all right? So let's try to write the few things we might be interested. So the first steps here for the optimization problem, we need to determine, okay, the knowns and unknown quantities. Okay, so first things, after you read the problem, we are say, okay, what is the quantity they tell us? So what is the information we know and what is the information, the variables here. Okay, so the second things here, just like we talk about the related rate, so maybe it will be very helpful if you draw a diagram. Okay, so the diagram, the graph is always very, very helpful, try to solve this type of the problem here. Okay, so now the next ones here is we're going to introduce notation identifying the quantity Q to be maximized or minimized. Okay, and the other variables. Okay, so for example, if you say, hey, I want to maximize the area, then maybe you say A is the area, that's what I want to maximize. And then the area maybe depend on the radius. Then the radius is one of the variables here. Okay, so the step number 4 here. So this one here is write the out, write the Q as a function of the other variables. Okay, and so this probably is the the one of the key step, of course, right? So after you identify the variables, after identify which quantity you want to maximize or minimize, and then you want to find the relation between these two. So this ones here, we say this probably is the one of the key steps, right? So you want to find the function of your Q and your variables here. Okay, so now let's take a look at what is number 5 here. Number 5, okay, so this is kind of like a key things here. So I want to rewrite if necessary. So sometimes your variable, you could have 2 or 3 variables, right? So I want to rewrite it if necessary. Then I want to rewrite the Q as a function of just one of the variable. So one of the variable using the given relationship. All right. And also we want to make sure we know determined because of you rewrite it, right? So we want to determine the domain on the domain of what? Of this Q's, right? Because you rewrite it. Okay, so this is also, I think is the very, very key is you want to rewrite into the just one of those variables. So probably also this probably will be the hardest steps here is try to find the relations between those variables here, and then how do you rewrite it? So that's why you want to change it to the one variables, right? The reason why you want to change it to the one variable, then you can use the calculus skills, right, to find the absolute extrema of Q on the domain inside this domain this here. Okay, so then what do we learn? Like to find the critical point, find the end point will be applied to find the absolute max or absolute mean inside this, you know, the intervals here. So the key things here is you want to find the relations for the variables. And then you want to rewrite whatever your objective function and as the one function as one of those variables. Like I said, probably this is the hardest step here. So, you know, like, of course, sometimes, you know, you have so many conditions, right? You won't be able to write down to one variable. So how about if you have like more than one variables, then how do I find the max and the mean? That's what we're going to, you're going to wait until we talk about in the calculus 3 here. We have a different methods here. Okay, so now let's try to follow those steps, right? So the 6 steps, let's try to follow those steps to do some examples, and then let's see how that work. Okay, so then here, the first example, they said a gardener wished to create 2 equal-sized gardens but enclose a rectangular area with a fencing divider in the half with the fencing down right at the middle, right? If she has 300 meters of the fence to use, what is the largest rectangular garden she can create? Okay, so let's do the step number 1. So what is known here? So I know the amount of the fence, right? 300 meters is what? This one we know is known, right? So it's a given. I only have that, okay? And then what is the unknown? It's a dimension. Dimension of the rectangular is unknown, correct? Right, so now let's, okay, so that's why this one not giving us much information here, right? So now let's take a look at the graph here. So we say, okay, let's do a graph. We said do a graph, a typical will help. So this is my rectangular farm garden. I put a right in the middle, right? So I would say, okay, let's label it. So I say, okay, this is my y, 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 y. And then this is x, x, x here. Okay. Now, so now we can label it, right? So then we will say the A is the area. Okay, so what do we try to do? We want to maximize this one here, okay? And x is the width, and the y is the half of the length, right? Okay, so now let's try number 4. Remember, we want to find the relation between all those variables. So this one here is not bad. So the relations here is A is equal to what? A is equal to the width times the length. So it's x times what? 2y, right? So it's 2xy. And This is what? This is the functions, right? So this is the function. What do we try to do here? We try to maximize it, okay? And then now, let's number 5 here. We want to find the relation between the xy, because right now the a has a function, the 2xy. We want to change it to one variable here. So how do I get a one variable? Because I have this conditions, right? So the condition tells us I have a total 300 meters. So I know in here, I will say the how many y's here? I have 4y plus 3x is equal to what? It's 300 meters. Now you can change x equal to y, or y is a function of x. So now I change the y equal to a function of x. So y will be equal to the 4. So this is 300 minus 3x. All right. Now in here, you say, oh, okay, good. So because the area is 2xy. So now I will be able to is 2x, and then here, this is the 4. This is 300 minus 3x, correct? Okay, so now I can simplify a little bit. So this is 2 and 4, so it's a half. So I have 150x, okay? And the minus 3/2 x squared. Okay, so finally, right, so did you see here? Finally, we said we changed this function to only one variable here. Okay, so after that, then the remaining will just be, okay, so I forgot. So we also need to take a look the domain of what? The domain of the domain of the a's, right? So because we know the 3x plus 4y is equal to 300 here, and we know that x has to be greater than 0, y have to be greater than 0, right? So I cannot have a, so I know my x value, the domain here, so should from the 0 to what? How many x? 3x, right? So from 0 to 100 here. Okay, so that will be, this will be my domains here, right? So that's what is our step tell us. Okay, now the number 6 here, step number 6, and then I can use my derivatives here. Okay, so I can say the a prime x here. So a prime is 150, then minus what, 2 move down, so it's 3x. I will set this one equal to 0. So I can solve x equal to what? Equal to 50 here, right? So 50, then you take the second derivative. The second derivative is -3. So if the second derivative is -3 by the second derivative test, so we know that x at is 50. This is going to give you a maximum point. Correct? So if x is equal to 50, then I back to the relation. So y is equal to the 300 minus 3 times 50 over 4. So y is equal to the 37.5. So now I know the maximum area will just be what is 2 times x times y, right? 37.5. So this will give me 3750 meters square. Okay, so this ones here is kind of like the pretty straightforward, and so the remember, right? So the number 4 and the number 5 probably are the hardest steps. After that, and then the number 6 will probably be, you know, the easiest one. And also, like, if because of the domain, right? So you know when the x equal to 0, then your area is equal to 0, and the x equal to 100, your area equal to 0, right? So you know the maximum area will not be happen on the domains here. Okay. All right, so now let's take a look at the second ones here, right? So okay, the second problem is here. Okay, so the second problem, so they tell us a cylinder cup is to have a surface area is 12 square inch of aluminum. So what is the largest possible volume for this cup? All right, so let's start with step number 1, find the known and unknown. So what is the known? It's the surface area. Okay, so the surface area is 12 square inches here, right? So the surface area is 1. And what is the unknowns here? Unknown is the volume. Volume is the unknown, right? Also what? The radius. I don't know how big is this cylindrical cup, right? And what other?